So given the polynomials p at x equals x squared minus 2x plus 1 and q at x equals 2x squared minus x plus 2, evaluate p at x times q at x. So we're given p at x. P at x is x squared minus 2x plus 1. Q at x is given by 2x squared minus x plus 2. So we have to evaluate p at x times q at x, or p times q. So expand. So we're going to take a distribution, we're going to apply the distribution law, x squared times this term minus 2x times this plus 1 times this. So we're going to write this as x squared, 2x squared minus x plus 2 minus 2x times 2x squared minus x plus 2 plus 1 times 2x squared minus x plus 2. Then we expand out, so this is 2x squared times 2x squared is 2x to the 4th, x squared, which is minus x cubed, x squared plus 2x squared minus 2x times x is minus 4x cubed. 2x minus x is positive 2x squared. 2x times 2 is minus 4x. Then we have plus 1 times 2x squared minus x plus 2. There's a lot of symbols in here, so we'll start off with the quadratic terms. I'll put a line underneath them. So this is a quadratic. There's no other quadratic terms, so that's good. There's an x cubed term, so I'll put a double line and draw an x cubed. There's an x cubed term over here. There's no more x cubed terms. I'll put a little arc for x squared terms. There's an x squared terms over here. There's an x squared term over here. So we still have linear terms, which I'll make an upper arc, 4x, and there's an x, nowhere else. Finally, the last term, I'll put a double arc for 2. Okay, so we have 2x4. So I'll finish that. I'll put a little dot, say I've completed that term. There's an x cubed term, there's an x cubed term, there's nowhere else, so this is minus 5x cubed. So I'm going to take care of this with a double, single dot, 2 dots. Now we have 2x squared, 2x squared, and 2x squared. That'll be 6x squared. I'll put little dots so I know that I've finished calculating these elements. Now we're left with 4x and x, which is minus 5x. We'll put a little dot saying we've finished these two elements. And then finally we have 2. So this is our final answer.